Parallel and perpendicular lines. Objective, to relate parallel and perpendicular lines. Okay, theorem. It says if two lines are parallel to the same line, then they are parallel to each other. Okay, so on this one, to draw a picture of this, now excuse my semi-straight lines. If I have line A and I have line B, now there's going to be little red arrows to indicate that they're parallel to each other. If I draw another line that's parallel to line B, we'll call it line C, then that means that line C is also parallel to line A. Another way to think about this is think about your notebook paper. All those lines are parallel to each other, and we could pick two out at random, and it's going to be parallel to another line on your notebook paper. Theorem said in a plane, if two lines are perpendicular to the same line, they are parallel to each other. Okay, what that means is that if I have my first line, we'll call this line M, and I have a transversal, we'll call this T, and it's perpendicular to line M. If I have another line that is also perpendicular to line T, call this line N, then that means that line M and N have to be parallel to each other. The other reason you can think of this, and this is from the last section, if I have right angles here and here, that means that my corresponding angles are congruent. And if my corresponding angles are congruent, the lines have to be parallel. So what it says in symbols, it says if M is perpendicular to T and N is perpendicular to T, then M is parallel to N. Example 1. Can you assemble the pieces at the right to form a picture frame with opposite sides parallel? Explain. Okay, so on this one, if you ever look at how a picture frame is assembled, we could take this 60-degree angle, excuse my drawing, if this is 60 degrees, I can put in my 30-degree angle, and notice right now I have a right angle right here. And since I have that right angle, this line, because if I start to make the other one, and this again would be the 60 and 30, here's another right angle. These segments are going to be parallel to each other, and then the 30, these guys right here, would also be parallel to each other because I could draw in the third one, and this would be my 60 and 30. So yes, it's possible. And again, it's because you're looking to make a picture frame, you're looking for that right angle right here. Theorem says in a plane, if a line is perpendicular to one of the two parallel lines, then it's also perpendicular to the other line. Okay, so what this is saying, if I was drawing a picture, is that if I have line N and it's parallel to line L, sorry, not parallel, perpendicular to line L, and I know that L and M are parallel to each other, so I'm going to say that I know that L and M are parallel to each other, then I know that M and N must be perpendicular. And it's because those corresponding angles have to be congruent. So in symbols, it's saying if N is perpendicular to L and line L is parallel to line M, then N is perpendicular to M. Example 2. Given in a plane, C is perpendicular to B, B is perpendicular to D, and D is perpendicular to A. It says, can you conclude that A is parallel to B? Explain. Okay, there's two ways we could look at this. I'm looking at line A and line B right here. Notice they're telling me that they're perpendicular. Those also represent my corresponding angles, so I could say that it's yes, they have to be parallel to each other because the corresponding angles are congruent. Or I could say yes because I have a theorem. This is justification. The theorem says two lines perpendicular to the same line are parallel. So you could use either reasoning to prove that A is parallel to B. Okay, lesson check. Make sure that you try the lesson check before you come to class and have it written out, so that way we can go through it together as a class more quickly.